What's happening, dogs? Mr. Allen here with some Pythagorean Converse. That's right, we're taking the greatest theorem of all time, putting a little spin on it, and we're going to use it to figure out if triangles are either a right triangle, an acute triangle, or an obtuse triangle. This is actually super applicable in real life. I got some other videos I will show you guys. Maybe I'll link them in here so you can check it out. So we're going to determine if the three side lengths in each example would create a right, acute, or obtuse triangle. And we'll need to justify it with our wonderful Pythagorean Converse. Well, why don't we write that down real quick, okay? I'm going to do so over here, all right? So my Pythagorean theorem is a squared plus b squared equals c squared, all right? So a squared plus b squared equals c squared. That would mean that it is a right triangle, okay? So if a squared plus b squared actually equals c squared, we have a right triangle, okay? No tricks on that one. Now, the next one here is a squared plus b squared, and then we'll say less than c squared, okay? Or in other words, my c squared is larger than the a squared plus b squared, right? We can read it backwards as well. It's a little bit, I find it to be a little more helpful to read it backwards. C squared is the larger one than these two. This right here is an obtuse triangle, okay? When my hypotenuse squared is larger than the sum of the two legs squared, we have an angle that is larger than 90 degrees rather than equal to 90 degrees or less than. And then obviously the flip is going to be true here. Maybe not obviously, but hey, whatevs. In this case, a squared plus b squared is greater than c squared, or how I like to read it, c squared is less than the sum of these two. Now I have an acute. Whoop. Okay? So this is my Pythagorean Converse. Super duper important. Screenshot that now or write it down, okay? Because we're going to be using it here in a moment, and it will cover up my wonderful logo here. But that's okay. All right, my logo. Yo-ro, you only round once. All righty, let's do some examples now, okay? So c squared is always my largest side, right? So this guy right here, that is my c squared. Always identify your c squared, your c value first, right? That's going to go into my formula. So I'll have 5 squared plus 12 squared. And then I like to put a little box here, 13 squared. Because I don't know if it's equal to, less than, or greater than, okay? So we'll do all the math now. 5 squared is 25. 12 squared is 144. 13 squared is 169. 25 plus 144, that's 169. 169. Are those? They are equal. So this is a right triangle. Woo! First one done. That's dope, man. This is dope. All right. 6, 7, 8. Beautiful. In order already for us. So I can just do 6 squared plus 7 squared. Little box. 8 squared. Well, 6 squared is 36. 7 squared is 49. 8 squared is 64. What's 36 plus 49? Let's be careful here. We got 70, 85. 85. Name that movie. Name that movie. Elf. It was when they were talking about how many Jack in the Box things that he's made. And they're like, what's your progress? He's like, 85. 85. Okay. I'm going to have to link in that clip. All right. We got a lot to do on this video here. Got a lot to do, but it'll be okay. So now my inequality is this way. And again, I like to read it backwards. C squared was less than the sum of the other two sides. Therefore, it is acute. It's an acute triangle. All right, next one. Woo! I got a radical in here, bro. What is this? What is this? So which one's my largest side? Well, the square root of 2 is approximately 1.4. And if you didn't know that, you should at least be able to, let's see here, guess that it's bigger than 1. The square root of 1 is 1. So anything bigger than 1, the square root of it should be bigger than 1 as well. And if I take a number multiplied by some number that's bigger than 1, I'm going to get a bigger number, right? Does that make sense? Do we follow that chain of logic? I know it's a little scary to see them be like, I don't know what that is, bro. And if you don't trust me, plug it into your calculator, okay? It'll give you a number that's bigger than 1. In any event, this is my C value. I didn't underline my C value on the last one. I'll do that just so it looks good. Okay. So I'll have 7 squared plus 7 squared, and then I have a box. And whenever I deal with these simplified radical type numbers like this, normal number times a radical, got to put it in parentheses, okay? Because both of these things get squared, all right? Now I have 7 squared is 49 plus 49. Over here, 7 squared, it actually goes like this. I square the 7, that's 49, and I square the square root 2. Those two cancel, and I'm left with times 2. Okay? A little bit of side math somewhere. I'll do it right here. When I do that, 7 root 2 is the same as 7 squared times root 2 squared. You can break it apart like that. You can distribute the exponent in. So I have 49 times these two cancel, 2, which gives me 98 over here. 49 plus 49, isn't that the same as 49 times 2? It is. It's 98 right here. And these two are equal. It is a right triangle. Woo! It's exciting stuff, you guys. Very exciting stuff. Last one, man. Hopefully I left it on the screen there. Sometimes my watch loads. Sometimes it doesn't load. Oh, well. I think it's on the screen. We got 11, 3, and 9. Well, which one's my biggest side? The 11 is my biggest side. That's my C. It's going to go in there for C squared. So I have 3 squared plus 9 squared. Little box action. 11 squared. 3 squared is 9. 9 squared is 81. 11 squared is 121. And if you're like, bro, how do you know all these off the top of your head? It takes a little practice as you use them more, especially in the Pythag unit and other, right triangles and things like that. You'll start to just remember them. Be like, oh yeah, okay, I got that one. I've seen that one a million times, right? So this is 90, and this is 121. Well, what do we have? This is less than that. So my C squared, as I like to say, I like to do this backwards. C squared is greater than, it's obtuse. Obtuse. Triangle. Woo! Boom. Pythag Converse. Done. In the books. Nice work, guys. You can handle any of these, okay? But again, super duper applicable in real life. If you're trying to square up a wall or determine if something is a right angle, you can measure a couple sides and then measure the hypotenuse, do the math, pop in in the calculator there and see if what you have is exactly right. Or if your hypotenuse is larger than what you expected, it's obtuse. If your hypotenuse is smaller than what you expected, then it's an acute angle, and then you can adjust from there. Kind of awesome. Really cool stuff. Hope you guys liked it. Keep watching the videos. Keep doing math. If you have any questions, let me know in the comments, or if you go to the school I teach at, find me in the halls. Peace out.